Okay, hello everyone. Let's go ahead and take a look at a continuation of the vector product. Now, being that we know that n is a vector, we need to go ahead and analyze the two properties that all vectors have. We know that it has direction and we know that it has magnitude. So let's go ahead and take a look at direction first. Now, how do we go about determining the direction of the vector? Well, one thing that you can do is you can always go ahead and just find out what that vector actually looks like by using your algebraic techniques. And of course, we can come up with the actual vector itself, and hopefully from that particular representation we can determine what the direction of the vector will be, especially once we go ahead and put it in standard position. Okay, or we can go ahead and use the right-hand rule. Now, let's go ahead and take a look at this diagram right here. Let's say that we have the A vector going in this direction, the B vector going in that direction. And what I'm going to do is I'm going to say at this point, being that these two vectors, this normal vector here and this normal vector here, are both normal, of course, to both A and B, if I was to go ahead and present a cross product, how can I tell visually which actual normal vector is going to be produced? Now, the way that we can do that is using the right-hand rule. First of all, you start by pointing in the direction of the first vector. So let's just go ahead and say for now, we're going to go ahead and start off with A cross B. Okay, so the first vector that we have then is A. So I'm going to start off with my right hand. I'm going to point it in the direction of A. And then what I'm going to do is I'm going to wrap to the second vector. Now what I mean by wrap is just roll your fingers towards the other vector. Now the thing is that you're going to have to keep your thumb standing because the direction of your thumb is the direction of the normal vector. So if I was to go ahead and start off with A and I was to wrap to B, then the normal vector that is produced is actually in that direction. Okay, so let's go ahead and see what happens then if I go ahead and take a look at B cross A. Now, if I go ahead and do the same right-hand rule, apply that to this particular diagram, what I'm going to do is, well, I could always go ahead and start off with B this way and then wrap, well, I don't know what angle is that? That's way more than 180 degrees. Well, technically speaking, I'm kind of like wrapping my whole arm now. So what I need to do is I need to go ahead and make sure that whenever I wrap, my wrap is less than 180 degrees, because otherwise my arm doesn't go that far. So in order to do that then, the only way that I can achieve this is by making sure that when I go ahead and point in the direction of B, I point in this direction, and then I wrap to A. So if that's the case, then I know that B cross A is actually going to be represented by this blue normal vector, and that's the direction of that particular cross product. Okay, so now let's go ahead and shift to the magnitude. Now, how do we go about finding the magnitude of the normal vector? Now, of course, what we could do is we could always go ahead and find the actual normal vector itself, and then just find the magnitude of the vector algebraically. Now, another way that you can do it though, and this is going to look very similar to what we dealt with the scalar product, is that if you already know the angle between A and B in standard position, then if you take the magnitude of A, multiply it by the magnitude of B, then take the sine of that angle and multiply all of that together, then what you'll come out with is the magnitude of the normal vector. So one of the things that you should notice as well, and here's a special note here, is that if we go ahead and take a look at this particular representation, which is the magnitude of n, then all I need to do then is multiply it by a unit vector in the same direction as n, and now I have a geometric interpretation of what the normal vector is. So what I can do then is I can write it like this. I say that the normal vector is going to be the cross product of A and B. Here's the magnitude of that normal vector, times it by u hat. Now what is u hat? U hat is the same thing as the unit vector in the direction of n, and you have the geometric interpretation of n. Okay, so here's a couple of important results that we want to prove, and you can go ahead and take a look at these on your own initially, but we will go ahead and discuss this together. Is that, for example, the A cross B is going to be, if that is equal to the 0 vector, then what that implies is that the A vector and the B vector are parallel to each other. Okay, can you visualize this geometrically? And in addition to that, can you prove that algebraically? Okay, with regards to number 2, we kind of already discussed that with the right-hand rule. So we have a very clear idea of what's happening with regards to the right-hand rule and how we can go ahead and determine the direction, because this is really all that's being talked about there. How do you go about showing that algebraically? Can you do that? Okay, and number 3, we're taking a look at the cross product of one vector and the sum of two vectors. And what we can come up with is that's really the same thing as the cross product of both vectors first with that first initial vector, adding those two vectors together to come up with a overall resulting normal vector. So the last one then would be the a vector cross the a vector, or the vector product applied to one single vector. And what you come out with is the zero vector. So again, can you see what's happening visually and geometrically? And can you also go ahead and prove that algebraically? Okay, so just to wrap up, we basically have the cross product of two vectors equaling another vector, and we're calling that the normal vector. And we need to go ahead, being that it's a vector, we need to be able to analyze both its direction and its magnitude. Okay, and we've discussed how to do both of those. Okay, so go ahead and take a look at some of these ideas here. Hopefully we can go ahead and prove them later when we meet. Okay, so we'll see you then. Goodbye.